So the ionization energy is not something new that we have already discussed about ionization energy. So energy needed to remove most loosely bound electron from a neutral gaseous atom. So on the enthalpy lesson later on you will be learning about this in detail. So then we would say energy that is required to remove 1 mole of electrons from 1 mole of gaseous atoms and to form 1 mole of unipositive gaseous ions, releasing 1 mole of electrons. So this is how we can indicate the first ionization. So if you can remember this equation, you can easily put that idea into words, which means from 1 mole of gaseous atoms, when 1 mole of electrons are removed, the energy needed to form 1 mole of gaseous unipositive ions, that is referred to as the first ionization energy. I hope that is clear to all of you. Now let's move on to the next part, the periodic trends in ionization energy. As we discuss about the atomic radius, even ionization energy is dependent on the effective nuclear charge and the average distance of the new electron from the nucleus. So here also the ionization energy increase. The reason, the effective nuclear charge increase. I could use a different color. So Z effective increases. As a result of that, the atomic radius decrease and the valence electrons are attracted more towards the nucleus. So that's the reason why. So it's hard to take off. Now for example, now I'll just indicate just the lithium atom itself. And then we can indicate the, let's say the carbon. So carbon has 2 electrons on the, and then first energy level and 4 electrons on the second, 2s2 and 2p2. So these valence electrons are attracted towards the nucleus. So this increase across a period, which means the ionization, to ionize, for these electrons to go off, for these electrons to go out of the system, you need to provide energy. So that is known as the ionization energy. So the more these electrons are bonded or attracted towards the nucleus, it's hard to break or take it off from the valence shell. So therefore more energy should be provided. So since effective nuclear charge increase across a period, ionization energy also increases. So you need to remember that. And then the distance of the electron from the nucleus also less. So therefore the ionization energy increase. And down the group ionization energy decrease, and towards the top ionization energy increase. So that is also because of the effective nuclear charge. So we can consider once more. So down the group, if we consider so lithium and sodium, so we can consider sodium and lithium. So sodium has 11 protons and lithium has just 3 protons. But then the sodium, the electrons are distributed in 3 energy levels. So 1, 2, and then we can consider the third energy level. So here in the second level there are actually 6, and on the third energy level there is 1. So this electron has less attraction towards this nucleus. This is the attraction towards the nucleus, so it is basically less compared to the electrons of lithium. So lithium, there are 2 electrons on the first energy level, the third electron is on the second. So the attraction is actually high. You can see this electron has higher attraction compared to the attraction of the electron in sodium, valence electron in sodium. So therefore the sodium, the valence electron is far away from the nucleus, so it's easier to take off this. It's easier to take off this electron away from the atom compared to this electron. Now in lithium, this electron is more tightly bound to the nucleus or attracted to the nucleus compared to the valence electron of sodium. So therefore, because of the effective nuclear charge Z effective actually decrease down the group. So there is less attraction felt by these valence electrons, and also there is higher distance for the valence electrons. So therefore it's easy to ionize down the group. Towards the top, ionization energy increases.